Hello, this is Chris Henderson, and in this video I'm going to show you how I processed my data from my LiDAR sensor. So the first thing I had to do was head out onto campus and collect my data. Here's my target, it's the fire hydrant in front of Anne Arundel Hall, and notice the extrusions out on the side where the valves are, the roundness and cylindrical nature of the shape, and also note that there's some noise in the background, so I'm going to have to take that into account when I actually process my data so that I don't have the extraneous points. So after I took my pictures, I translated them to my laptop and I processed them on Python. So on Python, I first used my colorpicker.2 code as I did in the previous homework assignment, and the only difference is I used a snip here and took a snip of the photo so that my noise would be taken into account. As you can see, and when I run, let me run this real quick. So when I run colorpicker.2, as you can see, here's where I drew my rectangles. When I actually drew them, they were blacked out, but they were pretty difficult to see, so I made them green for the sake of this video. But these were basically baits that the noise in the background, as you can see, where the majority of the noises was up here and like down here. Those things would be taken out of the pictures and make it easier to process the data and get an HSV mask. So after I found an HSV mask, I went to my datageneration.py file, and I also added the stip function so that I could run my pictures through this code and have them also have that same noise filter that I applied to my color picker. These are the HSV values I found for these particular images. So I'm going to run this real quick. Well, actually, I already did run it. Here's what I ended up getting. As you can see, it's a rounded shape, cylindrical, and you can clearly see the valve on the side right here. This is just one part of the actual fire hydrant. It's one of the 3 parts that I used to stitch together my data. As you can see, there's a lot missing right here, and it's mostly due to the lighting that I really couldn't control of. Obviously, in future takes, I'm going to try to process that a little bit better and try to maybe get some better data out on the field. But as of now, this will suffice. I got the general shape, and most of the noise has been eliminated. Just a few little points here and there. So after I did that, I processed everything in MATLAB. So here's my MATLAB code. It's basically the same as the code we were provided for the processing in the previous homework, although I did make a few changes. So I added 2 different angles here, and these angles are used for rotating the different parts that I could stitch them together. And these 3 lines, I import the data from each directory. So here's the first one I took, here's the second one I took, and here's the third set of data I took. I extracted the data and put them into different arrays. As you can see, here's the A data, here's the B data, here's the C data. But for the B data and the C data, I had to rotate them around the axis. So here, I use this function right here. These parts rotate the points around the Z-axis for the X values, and these do the same for the Y values. And then I added or subtracted a couple to kind of translate the data over to where my A data was, that it would look like it was connected. And then I did the same with the C values, as you can see down here. I just used the angle phi instead of theta. After this, I plotted the point clouds all in the same exact plot, and I ran the code, and this is what I got. So as you can see, there's definitely some roundness right here. Notice how the base is wider, and it gets narrow as it goes up top, like any fire hydrant is. If I rotate this a little bit, kind of show you a different perspective. It's a little bit finicky in MATLAB. But as you can see, so yeah, here's like the front view of where I took my original data from, and as you can see, it's definitely got that round shape to it. You can see where the valves are on the sides. The only problem with this data is that I couldn't really get the back portion of the actual fire hydrant. As you can see, it's pretty empty back here, and this is mainly due to the fact that that was facing the road, and there's not really any room behind it between the fire hydrant and the road. So that's just data I don't have access to at the moment. I may try to get more data, try to get different angles from the side and see if I can kind of finagle something back here. But for now, this is what I have, and it serves as a good starting point for the mesh that we'll do in homework 8. Thanks for watching. Bye.